thank our sponsors, especially Prisma Cloud. Prisma Cloud is the industry's most comprehensive cloud-native application protection platform, CNAPP, with the broadest security and compliance coverage for applications, data, and the entire cloud-native technology stack throughout the development lifecycle and across hybrid and multi-cloud environments. As always, I will be waiting for Q&A after the talk. Please raise your hand. We'll bring you the mic. That way YouTube can hear you. Please welcome Nick Frichette. Thanks.
Thank you all so much for being here. Hope everyone's had a good start to for CloudSec. There are a ton of great talks today on a wide variety of topics. And in this one, I'd like to focus in from an adversary's perspective. How can an attacker evade detection in an AWS environment by either disrupting or bypassing AWS CloudTrail? To cover this content, we have a whole lot to talk about. We'll just do a quick level set on what CloudTrail is and why hackers hate it. Then we'll talk quite a bit about disrupting CloudTrail. What options does an adversary have after gaining a foothold to try to disable or otherwise make things difficult for the blue team? We'll point at some real-world situations where this has occurred, and then also talk about some ways where we can deploy CloudTrail that fairly effectively mitigates this risk. After that, we're going to do a deep dive into bypassing CloudTrail. I've found over time a number of vulnerabilities that have allowed me to bypass CloudTrail in some way. Everything from simple permission enumeration up to and including just interacting with the service while evading CloudTrail. To do this, we'll do a crash course into the internals of the AWS API, how it works. We'll take a look at those vulnerabilities, and then we'll also explore the potential for automating the discovery of future bypasses. Now, it's worth noting all the vulnerabilities and issues I'll be discussing today have since been fixed by AWS. So this is less of a, if you're a red team or a pen tester, here are these things you can use, and more of a, how can we apply these techniques going forward? And we'll show that in at least one situation, we could do just that. There's a ton of great content in this talk, including some research that hasn't been made public yet, so I hope you enjoy. As for who I am, hi, my name is Nick Frichette. I do AWS security research, both as a hobby and as a profession. As a result of the research I do, sometimes I find vulnerabilities in the services themselves, and we'll be talking about a couple of those today. Minor side note, to support this talk, I have a bunch of references, documentation, notes, general information in the slide notes section. So if I mention something you're interested in or you'd like to learn more about, definitely check out the slides at that URL. I've also sat in the back for a couple of sessions, and I totally recognize that fonts can be difficult to read. So strongly encourage you to check out the slides there to see some of the things I'll be talking about. So really quick, I recognize that Forward CloudSec is a multi-cloud conference, and perhaps we have some folks who are more familiar with Azure or GCP. So really quick, what's CloudTrail and why is it a problem for bad guys? So CloudTrail is a fundamental cloud security service from AWS. It's responsible for logging calls to the AWS API, and it helps security teams answer the question of who did what when in an AWS environment. It has uses for allowing you to query those logs, to do threat detection if somebody's being suspicious, as well as the potential for auto remediation to just automatically repair any type of issue. So as you can imagine, security teams love it. It's fantastic. It has all these great uses. And for adversaries, CloudTrail is a major problem. There is a huge draw for an adversary to use IAM credentials, because with those credentials, they can do things potentially like privilege escalation, lateral movement, accessing resources, maintaining persistence, and so much more. And so as an adversary, you are incentivized to steal them and use them. But you run the risk that just about anything you'll do with them gets logged to CloudTrail, and then later on, gets sent to some SIEM, some data lake, some analytics tool, and suddenly you're caught. And speaking as a former pen tester, there's nothing worse than finally getting C2 on an EC2 instance, stealing those credentials, getting a little too excited, running them from your own machine, and then 30 minutes later, the SOC's messaging you saying, hey, it's super weird that these creds from a machine in Virginia are starting to phone home from Illinois. What's up with that? And then you're caught out. So, as adversaries, if we want to do something about CloudTrail, what options are available to us? In the event that we can gain a foothold in an AWS environment and either escalate privileges or simply steal credentials with sufficient privileges, we can attempt to disrupt CloudTrail, trying to disable its setup in the account, deleting the logs after the fact, and things like that. As a secondary option, we can try to bypass CloudTrail. I found a number of vulnerabilities that have allowed me to bypass CloudTrail in some way. And if an adversary does this, finds a vulnerability in an AWS service and is able to query the API, all without logging to CloudTrail, from the victim's perspective, the adversary is invisible. They have no way of knowing that this activity has taken place. And to be clear, this is not a misconfiguration. This is not something we can architect against. These are flaws very firmly on the AWS side of the shared responsibility model. So with these two options available, these will be the primary focus of our talk today. So, really quick, there's a couple different ways you can deploy CloudTrail in an environment. We'll start in its most basic form with account level trails. We'll work our way up with some attacks against those, and then discuss some alternative means to deploy CloudTrail that fairly effectively mitigates a lot of these risks. So in its simplest form, a CloudTrail trail is a configuration you can create in your account that describes where logs can be sent to, i.e. what S3 bucket, along with some additional configurations like integrity validation, encryption, the types of logs you want to store, and things like that. From CloudTrail, those get logged into an S3 bucket where you can retain them for the period of time of your choosing, and then your SIEM, your data lake, your analytics tool, whatever you're using, can consume logs from that bucket. So for an adversary who has gained a foothold in an AWS environment, they have two general attack paths that they can try to pursue. They can go after the trail, or they can go after the bucket. For a real-world example where this has taken place, Assistig has an excellent article about a threat actor they identified that they've called Scarlet Heel, who took a fairly simple approach to a complex problem, and once they had sufficient privileges, just called CloudTrail stop logging, which has the effect that logs don't get logged, and theoretically this would hinder a defender trying to react to it. Some additional options would be things like delete trail, just delete it. You could try to update the trail, so try to point it at a different S3 bucket. Since it's not the normal logging bucket, logs don't go to the right place, and thus they get missed by the analytics tools. Or you could try to do CloudTrail put event selectors. This is a configuration that describes the specific logs you do want to log. So for instance, if you set it to be something esoteric or niche, something like AWS recognition, this has the effect that it omits the more security relevant services like IAM, KMS, Secrets Manager, and things like that. From the S3 bucket side of things, a lot of the same general ideas apply. You can try and delete the bucket. You can try to set a different bucket policy, or so you try to set a different policy on the bucket to prevent CloudTrail from writing to it. You can just delete the logs, or you could try and do a put lifecycle configuration. And again, this is another real-world example of something that's happened. Unfortunately, Ubiquiti, makers of fine consumer electronics, switches, routers, IP cameras, and such, I'm sure some folks probably have some Ubiquiti gear. They unfortunately suffered a breach caused by one of their own insiders who then tried to ransom them, essentially. One of the activities that individual did after presumably the investigators started catching on is he changed the retention policy on the S3 bucket storing the CloudTrail logs down to a single day, presumably with the intention of trying to hinder investigators. Now, it's at this point that I did want to mention, in the event that this happens to you and somebody deletes your trail or deletes the logs themselves, or perhaps even non-maliciously, just accidentally, you still have access to all the management events that occurred so long as you get to it in 90 days. I think since a lot of us likely interact with CloudTrail through like a third-party SIEM or something like that, it might be reasonable to assume that, hey, if the infrastructure supporting the logs gets busted, we just lost those logs. But in reality, by default, CloudTrail is running out of the box with no configuration every time you create an AWS account. Even if you've never set up a trail before, it's still running. You can still pull those events from the CloudTrail API, or if you prefer a GUI, you can use the event history. Bear in mind that's going to be on a account-by-account basis. How can we prevent this? Probably the best way to go about it would be to use an organization trail. Organization trails are a feature of AWS organizations, and relevant to this context, they have a pretty important feature. Organization trails cannot be edited or deleted by principals in the member account. So even if an adversary gets administrator access or ** permissions, they won't be able to delete or edit the trail. As some additional options, if you're using Control Tower, it's worth noting that up until Landing Zone version 3.0, which was released less than a year ago, Control Tower was using account-level trails, which theoretically would open you up to some of the risks that I described, but thankfully, in addition, they included some SCPs to try and prevent that, and that takes us into SCPs. In the event that you can't use an organization trail for insert reason, SCPs are probably a great way to lock down who can mess with your trails or delete them. And with that out of the way, we get into the interesting stuff, actively bypassing CloudTrail. In general, there are three sort of archetypes for CloudTrail bypasses that I've identified: protocol mutation, undocumented APIs, and non-production endpoints. In order to abuse basically any of these, though, we have to know a little bit about how the AWS API works. I'm sure many folks have used, many folks' experience with the AWS API is through things like the CLI or maybe the SDKs. And these are great because it helps abstract away a lot of that complexity so that we don't have to deal with it. But if we're going to start attacking the API, we have to know a little bit about how it works. So a quick level set or a quick introduction to the AWS API. It's important to note that AWS is very big on what they refer to as model-first design. When they build a new service, before they write a single line of code, they first create a model that describes everything about that service: what the operations are, what the parameters for those operations are, and so on. And that model-first design carries over well into production. And we can actually extract out those models from the SDK. And this is an example of such here, specifically for the KMS service. And this model is important because this is how we know how to format our requests and what API operations are available to us. And so picking out just a couple important things from this model, we have the endpoint prefix, which is responsible for telling us the actual endpoint, or at least part of the endpoint that we'll need to communicate with the service. We have the operations, which is a little bit cut off at the bottom there. The API, or the operations of a model, are the actual API actions you can perform. So relevant to KMS, those are like list keys, create keys, list aliases, and so on. Now, arguably the most important part about this entire model is the protocol. The protocol is the part of the model that describes how we need to format our request so that it can be serialized on the client and then deserialized on the server. And as we can see here, KMS uses protocol JSON, specifically JSON version 1.1. Now, there are 6 protocols for the AWS API. Relevant to our discussion today will be JSON version 1.0 and 1.1. And again, the protocol describes how the request is formatted. So continuing our KMS example, since we know it's JSON version 1.1, we know it's always going to be a post request. It's always going to go to the base path, not like /API or something like that. We know it'll send content as JSON. Specific to JSON, there's an additional header, the X Amazon target header, which is 2 terms separated by a period, the target prefix, and the actual operation. In case you're wondering what Trent is or who Trent is, sometimes AWS includes what appear to be internal code names or service names in their models. And as for Trent, credit to Aidan Steele for digging this up. Trent is a reference to the Alice and Bob naming convention, in which Trent is the trusted third party in cryptography. The final part of the protocol or the format that we need to know is the content type, because specific to JSON 1.0 and 1.1, the version of JSON is sent as a header. And so this takes us into our first potential CloudTrail bypass. If there are these really well-defined structures and formats for how API requests should look, what happens if we start mutating our requests or sending formats in an odd way? Interesting thing about that JSON one, if you sent at the time a 1.0 header to a 1.1 API, you would get back different HTTP response codes depending on if you did or did not have sufficient permissions to invoke that action. As an example, if you did, you would get back a 404, and if you did not, you would get back a 403. And critical to all of this, regardless of what permissions that principal had, none of it got logged to CloudTrail. And so what this meant was, through this technique, if you stole IAM credentials, you can brute force or identify what permissions you had for the JSON 1.1 protocol, all while evading CloudTrail. And at the time, this affected over 645 actions across over 40 services. And so for a real-world perspective on what you would do with this, it's important to note that adversaries often don't have a clue as to what permissions the credentials they've compromised have access to. They're completely in the dark. Unless they can source that information from a third party, something like infrastructure as code stored in Git, or perhaps maybe internal documentation or wikis, or if the credentials have IAM permissions, they could try to do it that way. But outside of these situations, attackers are normally very much so in the dark as to what they can access with credentials. So a common technique is to simply just try and see what works. They'll try different API actions. If they succeed, good, and they know they work. If they don't, well, they know they don't work. And you can even use a handy tool called enumerate IAM to sort of brute force this at scale for you. Now, the good news for defenders is that this behavior is fairly easy to detect. It presents as a sudden uptick in access denied errors or in a principal performing actions that they have never performed before. And so it's often a golden opportunity to detect adversaries who are relatively early on in the intrusion lifecycle and hopefully shut them out. But if we apply the technique that I just described, an adversary would be able to enumerate permissions completely silently, avoiding CloudTrail and evading detection. Defenders would lose out on an amazing opportunity to catch an adversary, and for adversaries, they can enumerate hundreds of permissions over tens of services. If you're interested in this topic, I have a ton of additional information and some proof of concept scripts to run. For its time, this was an amazing tool for red teamers and penetration testers to very quickly identify what they could do with some credentials and then try and continue their attacks. This takes us into the second topic, which is undocumented APIs. I think undocumented APIs have been sort of a hot topic amongst the cloud security research community lately because we can potentially use them to perform actions that we weren't aware that we could, or as we'll see, we can sometimes bypass CloudTrail. Now, I recognize it could be a little awkward to describe undocumented APIs because we call them undocumented, but I'm sure somewhere inside of AWS, there's a wiki or documentation or something that describes what these API actions are and what these services are. It's just, as mere mortals outside of AWS, we can't access that. So for our purposes today, I'll define an undocumented API as one that is an API that exists within AWS that doesn't appear in the public documentation or doesn't appear in the SDKs. And to be clear, just because an API or a service is undocumented doesn't mean it's vulnerable. There are thousands of API operations which are undocumented and are completely benign and uninteresting. But sometimes they can be vulnerable. As an example, earlier this year, I found 2 minor cross-tenant vulnerabilities in the app runner service. These operations were marked as internal only, except I could execute them from my normal AWS account. And these essentially worked by you provided a AWS account ID, any AWS account ID, even ones you don't own, and it will return you information about the app runner service in that account. So the actual problem with undocumented APIs is how do we find them, right? As compared to the documented APIs, there's the SDKs, there's the documentation, there's all these things we can learn about to know how to interact with the service. For the undocumented APIs, we're kind of in the dark. How do we find these things short of getting some insiders at AWS to leak the info? Please don't do that. So the way that I have found has been to actually abuse the console. It might sound a little weird to say, but the AWS console is as much a client of the AWS API as the CLI is. in order for your browser to know how to format requests to send to the API, it has to know the models and all the information to actually sign those requests. And as a result, the model files, including what I showed earlier in the KMS example, exist in the JavaScript that gets sent to your browser. And so what you can do is you can crawl the AWS console, go through all the front-end JavaScript that gets sent, and then extract out those model files. And for whatever reason, those models include internal-only APIs and some undocumented APIs that we can potentially use. If you're interested in this topic, I have a GitHub repo where I have all the models that I have collected. And in a couple weeks, I'd like to release a blog post with some additional information as well as the automation I'm actually using to crawl and extract out these models. But if you did what I just described, you would eventually find an undocumented service called IAM admin. Now, IAM admin is interesting because it interacts directly with the IAM service, and it's actually a service you've likely used before, you just didn't know it. If you open up the AWS console, hit F12 to open up your browser's network tab, and then navigate to the IAM page, you will see calls to the IAM admin service. Now, IAM admin is kind of weird because specifically the operation names sound vaguely familiar to IAM actions, but not quite. So as an example, there is IAM admin list access keys from multiple users. It sounds a lot like IAM list access keys. And again, we can go through the JavaScript and we can extract out all of the operations that are available to us with IAM admin. And what's interesting is if we invoke these actions with a user or role with no permissions, we get a strange error. Specifically, as an example, if we invoke IAM admin list access keys for multiple users, the error message we get back is user no perm is not authorized to perform IAM list access keys. And so it's through this way in an undocumented API that we can use IAM admin sort of like a proxy to invoke the real IAM actions and get those results. Now, if we did that over and over again for all the operations we found, we would then basically create a map between the IAM admin methods and the equivalent IAM method. And it's based on this that it becomes sort of clear the purpose of IAM admin, especially with things like list groups for users, plural versus list groups for user singular. It appears the purpose of IAM admin was to be sort of like a batch operation for the normal IAM API. And in the context of the console, it makes a lot of sense. It's a lot more efficient and performant to have a single call for list access keys for multiple users and pass in 50 usernames as parameters rather than 50 individual IAM list access keys calls. So now the question is, what does this show up in CloudTrail? IAM admin or IAM? As it turned out, it showed up as neither because it didn't log at all. And so it was through this method that we could use this undocumented API to perform IAM actions all without logging to CloudTrail. And this matters because this is another great opportunity for the defenders to detect enumerative behavior, list access keys, list groups. Attackers are trying to find out what's around them and what might be available to them. And there are a lot of commercial SIEM products that wouldn't detect this type of thing out of the box. As in a random example, GuardDuty has a finding for IAM user anomalous behavior that would have caught onto this, but through this method, it didn't show up in CloudTrail, so it couldn't see it. And again, this has since been fixed, but with the sheer number of undocumented APIs that are out there, it does make you wonder what other APIs behave in this way, sort of acting as a proxy for normal API services. And this takes us to our final archetype for CloudTrail bypass, and that is through non-production endpoints. I feel very strongly that non-production endpoints are the most likely to return future bypasses with relatively little effort. And I'll talk a little bit about why that is. Just really quick, in general, when you interact with an AWS API, the endpoint, the URL as it were, that you're interacting with will be different on a service by service basis and a region by region basis. And so typically the format of that endpoint will be servicename.region.amazonaws.com. And as continuing our KMS example, to talk to KMS and the US East 1 region, that would be the endpoint you use. Now, This is an example of a production endpoint. This is what the SDKs use, this is what the console uses, this is what they expect you to use. It may surprise you to note that there are a ton of non-production endpoints. And these endpoints appear to exist for a wide variety of reasons. Everything from alpha, beta, gamma environments. There is staging, pre-prod, performance, integration. There is preview builds. They're alphabetical, A, B, C, D, F, G. And these are just a few examples here. This is certainly not the exhaustive list. Now, the thing to know about non-production endpoints is that they don't exist for every service. They seem to kind of come and go over time. In general, I've been tracking or sort of cataloging them since April, and that number has sort of steadily increased at approximately 1 to 2 per day. But they do sort of recycle, they sort of churn rather than just being added on top. The interesting thing about non-production endpoints is that they have potential for defense evasion purposes outside of CloudTrail bypasses. And we'll talk a little bit about what those purposes are in just a moment. To level set and sort of like start off easy, KMS-A is an example of a non-production endpoint that has access to production data and does log to CloudTrail. And if you wanted to, you could use this the CLI action, AWS KMS list keys, perform the endpoint or provide the endpoint URL parameter, and then be sure to include the https://, and you should be able to use that endpoint completely normally. Any resources you create with that endpoint should appear in the customer partition, it'll show up in the console, and vice versa. Now, I'm being really specific, specifically because while this is an example of having access to production data and logging to CloudTrail, sometimes the inverse is true. There are some non-production endpoints that exist that do not have access to production data and do not log to CloudTrail. I recognize for those in the back, this font is tiny, so I'll narrate. Here we're doing an SNS list topics in the US2 region, and we get a response, we get a topic because there is one. We then immediately do that exact same thing again, but this time with the endpoint URL SNS-gamma. And you see, we don't find anything, presumably because this environment is isolated from production resources, in the same way that presumably your pre-prod environment is isolated from your production environment. Now, the major bummer here is that SNS-gamma does not log to CloudTrail. So if it did have access to production data, that'd be great. We'd be able to pull those resources and use them completely silently. But just because it doesn't have access to production data doesn't mean it's completely useless to us. If you'll notice, we still got a response. It's empty, but it's there. It's not like we got an access denied. So somewhere, IEM took a look at the permissions of the principal invoking the action and said, hey, you're authorized to do that, and it let it go through. And critically, it didn't get logged to CloudTrail. There's only one event because we invoked it completely normally up here, but it didn't see the second one. And so it's through this method that we can potentially enumerate permissions completely silently, much the same as we could with the protocol mutation technique that I described earlier. And so again, this raises the question, if you're an adversary and you're trying to enumerate what permissions you have access to, why would you ever use the production endpoint, the basic simple endpoint that runs the risk of generating a bunch of logs and maybe getting you caught, when if there is a non-production endpoint for the service you're interested in that doesn't log to CloudTrail, you can use this to evade detection. If you're interested in this technique, that endpoint should still work as of this morning, and in a couple weeks I intend to release a blog post with some more details and information, as well as a data set of non-production endpoints that fit this criteria. Another potential use for non-production endpoints for CloudTrail bypass is what I've been loosely calling event source obfuscation. So again, tiny font, I'll narrate. Here we're performing IVS list channels in the AP Northeast 1 region. We get a channel back because there is a channel in that region. We then do the exact same thing again, but this time, again, we do the endpoint URL IVS-gamma. And you see, we get a channel because it's there. So presumably, this endpoint has access to production data. So, good news, things are looking great. Does it log to CloudTrail? Well, it does, but it does it in a really weird way. If you'll notice, the initial we get two events list channels, which is right. The first one, the event source is ivs.amazonaws.com, which is also correct. But when we use the non-production endpoint, the event source becomes gamma-starfruit. I don't know what starfruit is. I presume it's an internal name or like a code name for the service, but it's not in the model either, so I really don't know. But this has the effect that we're able to invoke an action and get production data, but there's a different event source. So to my mind, there are two potential uses for this as an adversary. One, it's important to note that there are a number of SIMs that use the event source as a part of their rule creation. And if you find a non-production endpoint that has production data access and you start doing this, you will end up bypassing those SIMs and those rules specifically because it's not ivs.amazonaws.com, it's gamma-starfruit. The second potential use for this is in sort of forensic scenarios. Say, for example, you are reacting to an intrusion and you want to pull all the logs for an affected service during a particular time frame. So you might just go, okay, give me all the logs for ivs.amazonaws.com. Well, that's not going to catch up on this, and so it's not going to get identified. And you may be able to evade detection because they're not looking in the right place for those activities. And I should be super clear, this technique is super rare. I've only seen it in like a handful of non-production endpoints, but this is an example of it working. And our final use for non-production endpoints in defense evasion purposes, as you might have guessed, there are some endpoints that do have access to production data and do not log to CloudTrail, and that's exactly what we saw in Service Catalog. They had Service Catalog-Gamma. You could send requests to it, and it would allow you to interact with the service while evading CloudTrail. Now, to sort of continue on describing how weird non-production endpoints are, what was interesting was when we tried to perform a write action against the service, so like creating something new or modifying it, we would get an error. Specifically, access denied. The caller doesn't have permission to call this API, which, as you can imagine, was a huge bummer for me. But interestingly, it didn't actually do anything, because every time you would try it, you would get this error, it would still go through completely fine. So as an example, I tried to create a portfolio called "This was made while bypassing CloudTrail." I get the error message, and then it still went through totally fine. Still was able to create the resource. If you're editing something, that change would persist, and it worked totally great. So it's through this method that we could use this non-production endpoint for the Service Catalog service and allow us to get resources, modify resources completely silently, all without logging to CloudTrail. Now, early on in this section, I mentioned that I thought that non-production endpoints would help deliver future bypasses with relatively little effort. And the reason I said that is because it did. See, after the success of the Service Catalog stuff, I started getting very interested in non-production endpoints. How could we use those for additional defense evasion purposes? The challenge was very much like undocumented APIs. How do we find them, right? There's no centralized location, at least outside of AWS, where you can get them. So I built some automation that on a daily basis, what it does is it goes out to the Bodo core library, pulls out all the models, and then starts brute forcing those endpoints. And the inputs for that brute force are things like certificate transparency logs, subject alternative names and TLS certs, passive DNS, random guessing, and eventually, as it brute forces endpoints, if it succeeds in finding one, it resolves to an IP address. We then try and perform a bunch of list, get, or describe operations against that endpoint, and if it succeeds, it then forwards it on to Slack for further human review. And it was through this process of sort of automating the detection and sort of brute forcing it over time and at scale that we eventually found a new CloudTrail bypass for the event bridge service. Very similar story to Service Catalog. The normal endpoint was events.region. Well, this one was events-b, and for whatever reason, read and write actions did not log to CloudTrail. And additionally, sort of further cementing how weird non-production endpoints are, This one had no error message for read-write actions, or sorry, specifically for write actions. Went through totally fine, totally normally, nothing weird about it. We haven't blogged about this one, so I did want to mention this too has also been fixed, and a major thank you to the AWS Security Outreach team for their help in getting this resolved, as well as many of the previous issues as well. I do have this automation still running on a regular basis, so if I identify any more CloudTrail bypasses, I intend to hand them over to AWS so that they can be fixed. And that has been a summary of all the different ways that I have found to bypass CloudTrail. If you are a security researcher or somebody who is interested in AWS security research, I strongly encourage you to check out some of these techniques and try and apply them to future bypasses. Or perhaps you'll find a completely new way to bypass CloudTrail. And with that, thank you so much. I'm happy to take any questions. Thank you again.
Talk was super fun. We had a couple questions on Slack. The first for IAM admin. Does it represent what you're doing as the user or as the IAM admin service itself when it shows up in CloudTrail?
Good question. It's the user itself. This was not a situation where we were abusing an external service or having that show up in CloudTrail.
And then there are a couple questions you may not have the answer to around trying to understand kind of what's going on inside AWS that leads to this. And so one of the questions was, it seems like different services have inconsistent expectations for when they go to CloudTrail and how they use CloudTrail. Do you have any sense of like why that is? What's the internal configuration or internal sort of process that leads to these different outcomes?
Good question. I don't personally know. I've never worked at AWS. With some friends that I've talked to, it's my understanding that there's sort of a prioritization in terms of like ship features versus add-on certain things, but honestly, I couldn't say.
Fair enough. Cool. Other questions?
I suspect the answer to this is going to be a little bit of yes and a little bit of no, but by nature of the, can you go back to the CloudTrail slide really quick? The one that you've like had one log in CloudTrail and one log not. I assume by nature of one of those coming from something other than a known event source that we could potentially mitigate at least some of these attacks by sticking, say, an SCP on my org and then whitelisting services with the AWS called via condition.
Was it this
Yeah,
this particular?
exactly that.
That's an interesting idea. I've not actually tested it, but that'd be worth trying out. As far as I'm aware, that I know it's tiny, but that endpoint should still be active as of this morning. So definitely be worth a try to see if that would prevent it.
Nice. If I find out, I'll shoot you an email.
Sure, please do.
Thank you.
So in general, it seems that the stance is that anything that accesses production data without being logged is something that AWS is going to make an effort to close very fast. And like the SNS Gamma example, everything that does only allows that permission enumeration but doesn't access production data is not necessarily a priority to close very fast.
It's a good question. That is also my understanding. In talking with AWS, in particular the protocol mutation stuff, at the time that I reached out to them, they were very much, that's intended behavior. 10 months later, though, they did fix it. So it's one of those things of, we kind of, sometimes maybe you have to pressure AWS or point out the uses of it. But for now, at least, as far as I'm aware, there's no intention to fix that behavior.
Another Slack question. Do you have any indications that AWS watches some of these non-production endpoints for anomalous usage? Have you ever sort of gotten outreach or observations as a result of your testing?
No, I've never been contacted by AWS for any of the really sketchy stuff I've done.
Makes sense. Any other questions?
So you mentioned that you've been looking for like undocumented APIs. Are you also looking for like unreleased services when you're doing that scraping?
Yeah, so it's funny you mentioned that. Those do actually pop up, and I've been able to see operations for things that are like still in beta or still out. The one sort of challenge is I've seen them and I've like tried to use them, but they don't appear to work on the production endpoints. So then you try to find the non-production ones or wherever they are. But yes, you can totally see stuff before it's officially released.
All right. Well, thank you, Nick. That was super fun.
Thank you, everyone.
Next up is lunch break. In the next few minutes, they should be setting up boxes.